So with the ketones, there's this double bonded O, and it's called a carbonyl group. That's for future references. If you ever OHs are hydroxyls, carbonyls are double bonded O's. Okay, so with ketones, you have this carbonyl double bonded O that's like sandwiched in between carbons. It's never on the end. If it's on the end, it's an aldehyde. So if you had a double bonded O and it was over here or over here, it's an aldehyde. But since you've got a middle part, it's a ketone. Okay, it doesn't have to be exactly in the middle. It just has to not be on an end. So if you had like 20 carbons, okay, and you had a double bonded O anywhere that wasn't on the first or the 20th, it's a ketone. If it was on the first or the 20th, it'd be an aldehyde. Good. And the way you name it is just put one. So ethanone, okay, pentane 1, pentanone. It'd be 5 carbons with a double bond. And you have to tell like where it is. So like 2 pentanone, it's on the second carbon. 3 pentanone, it's on the third carbon. Okay. Carboxylic acids. What you do is you take an alcohol, a hydroxyl group, and a carbonyl, and you put them together. And that forms a carboxylic acid. These are probably the most important functional group that we will talk about. Sometimes you'll see it labeled COOH, okay? And it looks like it's like, I don't know, COOH, COOH. That's, biologists use that a lot because these are found all throughout the Krebs cycle. I mean, every step of the Krebs cycle involves a carboxylic acid. Malic acid, formic acid, pyruvic acid, lactic acid, you name it, it's an acid, it's a carboxylic acid. Okay? So there's that COOH group, what I'm talking about here. And the way you name it, it's just the longest chain and then oic acid. So like if it was 8, it'd be octanonic acid. If there was 3 of them, then it would be propanoic acid. So again, they're, like I said, they're found malic acid, that's part of the Krebs cycle. Pyruvic is part of the Krebs cycle. Citric is part of the Krebs cycle. Oh, go away. And then you get these more complex structures down here, which is like parts of plants. Okay. Yeah. So pretty important. Last one, ether. The reason why they're called ether, and this is the first time today I've made this joke, it's because there's something on either side of the oxygen. Okay? Yeah. Ethers have like, and the way that we're going to name them this year, we're going to make it way simpler. You just find out what the alkyl on each side of the oxygen is, and then you just put them in alphabetical order. So like in this case, you've got an ethyl and you got a methyl, so it's ethyl methyl ether. And it definitely sounds like you have a lisp. Ethyl methyl ether. If there was like a propyl and the methyl, then it would be methyl propyl ether. You just put them alphabetical. So how many ever carbons there are on each side of the oxygen? Just name it. So if there was 6 of them, it would be heptyl. And if there was 5 on the other side, it would be pentyl. So it would be heptyl pentyl ether. Ethers are really, really super important in manufacturing, and also they used to be used as like the primary anesthetic. Not so much anymore because it's flammable and they don't want operating rooms catching on fire. But it does knock you out. It puts you to sleep. They use it in the manufacturing of opioids. Okay. I don't really understand like how it works, but it pulls off non-essential parts. So it purifies things. So yeah, it's kind of important functional group. Okay, that's all I got for that. All right, so now the next part is the chart. So if you get your chart out, and let's go through it. All right. So the alkyl is already done for you. Remember, alkyls are baby alkanes. Okay, they're alkanes that are on a smaller. They're smaller alkanes that are on larger alkanes. So the R, everybody remember what the R stands for? It's just, it could be one carbon or it could be 100 carbons. Okay, it's like X in math class. Okay, it's a variable. It's just resonance structure. All right. So for alcohols, you have a bunch of carbons, and then there's an OH. Now, the OH could be on the first carbon, second carbon, third carbon, or whatever. So that part doesn't matter until you go to name it. And the suffix that you use is OL. Okay, so like if we had something like 2-pentanol, 2-pentanol. 2-pentanol would look something like this. You draw out your pentane, 1, 2, 3, 4, 5, and then off the second carbon, you'd have an OH. You guys see that okay? So it's pentanol, 2-pentanol. 1-pentanol would just be off of the first carbon, and then 3-pentanol would be off the third carbon. Okay with that? Okay, aldehydes. Aldehydes have these carbonyl groups. Alcohols have the hydroxyl groups. So it's just typically you don't just see an R with a double bonded O and an H. They usually draw it out like this to designate that this part right here that I'm circling, if you guys can see that, that is the aldehyde. Because you can't have it on any other part. It has to be on the end. So they designate that last carbon or first, whichever one you want to. Now it's the first one. If I turn it around like that, right? Because we read left to right. But it's on the end. So it's a carbon with a carbonyl, a double bonded O, and an H. You add Al to the end of them. And then you don't have to give a number. Why don't you have to give a number? Because it's always on the first or the last. Okay, so it's just assumed. So if you had something like, let's go with hexanal, hexanal, I think is the way it would be pronounced, hexanal. You just draw out your hexane, 1, 2, 3, 4, 5, 6, and then you can do it a couple different ways. If you look on the internet, it'll probably have an extra C here. Okay, so they'll put a C like right there, and then they'll draw the O and the H like that. Okay, or you could do it this way, 1, 2, 3, 4, 5, 6, and then just put your double bonded O, and you don't even need the H, I guess, but you'll see it drawn both ways. This, I think, may confuse you guys a little bit because I don't typically draw the C's, right? But remember, the line just indicates that there is a C there, and they're just saying that that part right there that I'm circling, I'll highlight it. That right there is the aldehyde. It's the C double bonded O with the H. Okay, if you can see that very well. And those two lines just mean that it's a double bond. Ooh, that's much better. Okay, haloalkanes. They're either going to be, and the X can be an I, an F, a BR, or a CL. Okay, so the way that you name these things are iodo, chloro, bromo, or fluoro, and you got to give the number. So like if you had 1 chloro butane, That would be 1, 2, 3, 4, and you'd have a Cl like that. And then carboxylic acids, typically, again, like the aldehydes, and remember, carboxylic acid is a hydroxyl and a carbonyl added together. So it's like an alcohol and an aldehyde had a baby. Because this is the alcohol, right? And this is the aldehyde. An aldehyde and I don't know, they form both. It's this whole thing is the carboxylic acid. Okay?
Is that butane?
What's that?
The chlorobutane, is that butane at the end of the chloro?
Yeah, I put butane. Yep. Yeah. So, and the way that you in these are oic acid. So, like, let's just go simple here. Propanoic acid. So, just draw yourself out of propane. That's just going to be, like 3. And again, a lot of times they'll have the C drawn out here. And so then they just put a double bonded O and an OH. So the carbonyl and the hydroxyl group added together. And again, there wouldn't be anything wrong with just doing it this way. Like that. Same thing. Okay. Ether. Just put an R on either side of it. I just can't let that one go. And to kind of distinguish between them, just put a little mark there and it'll let you know that they're 2 different R groups. And it's alphabetically the alkyl, and then the alkyl, and then ether. Now you'll also see it, and I'll go ahead and say this. They'll also use like oxy in between the 2 of them, so it could be like meth oxy propane or something like that. I don't want to show you that, but just for later on, there's 2 ways that they name ethers. We're just using this simple one. They're actually both pretty simple, but we're going to use the really, really simple one. So let's say we had methyl propyl ether. You just draw a methyl, right? Because there's just going to be 1 carbon right there. And then draw a propyl. 1, 2, 3. Because there's 1, 2, 3. And then our ketone, this is sandwiched in between. So you see it like that, and then sometimes you'll see it like that. Remember, it means the same thing because there's a C right there, right? Anytime a line comes to an end and there's nothing there, there's a C. But they also designate it like this. And it always ends in 1. So like 2 pentanone. Pentanone. It's pentane with 1 on the end of it. 2-pentanone. And then, if you want to draw it out, if you want to use the C here, you can. So 1, 2, 3, 4, 5, or you could just do it like this, and then just put your double bonded O right there on the second one. Questions on the chart? Again, this is primarily what your quiz is going to be on Friday. Like I'll just give a question. I'll say, what is the general formula for alcohols? And then it gives you like these choices. So it'd be R with the hydroxyl. Okay. All right. One thing I didn't cover, I should have put down here, and this is pretty simple stuff. It's just kind of a review, but are the cyclos. So with the cyclohydrocarbons, just remember all you're doing is you're just taking two of the hydrogens, you're losing them, and you're taking the chain and turning it in on itself. So the end and the head end up bonding together. Okay, so the simplest one would be like cyclopropane. That's the smallest one you can have because it's just three C's forming a triangle, and you'll just see it drawn like that. I can actually connect my triangle. Okay. You can also have alkenes and alkynes turn into cyclos. So like if I had cyclohexene, it would look like this. Draw your cyclo out, 6 of them, and then you put a double bond. And you're like, well, where do you know how to put the double bond? Well, if there's no other functional group in it, just put it wherever you'd like, and that would be 1. Okay. Now, if you had like a chlorine or something other else on there, then you need to put the numbers. You know, if you got multiple functional groups on the same one, you need to make sure that you tell where it is. And also, don't forget, since these are bonded here, you only have, so this thing actually, if you look at the number of hydrogens, if you draw this out, you've lost hydrogens here. Because as of right now, there's a double bond right here, right? So this thing only has 1 hydrogen. This one has 1 hydrogen. So if I give you like a test question or quiz question, and it's got like, you know, something like this garbage here, you can't do that because there's 1, 2, 3, 4, 5. There's 10 electrons around there, and you couldn't do that. Okay. You know, or if I did this and I said, well, how many hydrogens is around the first carbon? Well, it would be 0. There's not any hydrogens around the first one because they're all occupied by something. Okay. That's all I've got. If you guys, do you have any questions over alkenes or alkynes? Are you good on those with the doubles and triple bonds? Yeah. Yeah.
So if you have like cyclo and then like hexene like that, but it doesn't have like any of the like the halogens or anything,
Yeah.
would the formula still work, or would it
No.
not work?
The formula for cyclos is this. Because you lost those 2 electrons, right? Or I'm sorry, you lost the 2 hydrogens. You gained the 2 electrons. Okay. But yeah, it does work if there's no other functional groups. Yeah. Or it's not, well, this has to be a hexane. It can't be an ene. If it was an ene, it'd be -2. And if it was an ine, it'd be -4. But I'm not going to make you do that. But that's what you would do. So, all right. Let me shut this off. And we're going to do a lab today.